Uh, we're going to begin our own class. Okay. All right. So we'll be looking at the transport layer today. The transport layer. And the transport layer um, is a very, very interesting part of this particular training because it concerns security. And security that it concerns, especially those of you that will be looking at network security in the future. There's a lot of features that you will learn from here. Okay. Transport layer is the fourth layer in the OSI model. And we're going to be explaining the purpose of this transport layer and managing the transportation of data end to end. We're going to look at the two major protocols that run on it. We have the TCP and the UDP. These are the two protocols that runs on it. We're also going to look at the concept of port numbers, and then we'll look at the communication process, reliability and flow control, then UDP communication. So let's look at transportation of data. Now, when you say transportation of data, you're looking at the concept whereby data moves from one device to another device. The devices may be close by or they may be very far, okay? They may be within the same LAN or they will be within a WAN, depending on wherever they are. It could be an end device, intermediary device, or a core device. The transport layer is responsible for this logical communication between applications on different hosts. That is its major function. And the link between the application layer and the lower layers that are responsible for network transmission is the job of the transport layer. So you see that the transport layer moves data between applications because it is from the transport layer, then you have the application layers. Okay, the application layer is where you generate this particular data. Now, the transport layer is responsible for your transportation of this data. So, when it is looking at the concept of transporting this data, it has certain responsibility, one of which means tracking individual conversations. Because the message is sent from a source to a destination, you can track it, you can monitor it. Another thing it does is segmenting the data and reassembling it. Okay, the data is living and the size of the data is bigger than the channel that is conveying the data. So what it does is that it segments it, it breaks it into small segments and then numbers this segment. And then it sends this data in piecemeals. And then by the time it sends them, if they reach the destination, they will be reassembled. So that is also the job of the transport layer. It also helps in adding header information. Remember, we said the header information is used during the encapsulation process or the decapsulation process, where you add information about the data or about that layer, especially that is meant for the next decapsulation process. It also helps to identify and separate and even manage multiple conversations. Okay, especially when you are doing multitasking on your system. You have one system, you are doing streaming of video, you are doing online chatting, you are browsing the page, you are doing instant messaging, you are sending email, all at the same time. At the same time, you are doing all these things, multitasking on your laptop, on your phone, is the transport layer that helps you that helps you maintain your conversations in each of these pages. Okay. So the transport layer has two major protocols. Like we said, it has the TCP, which is transmission control protocol, and it has the UDP, which is the user datagram protocol. Okay. IP does not actually specify how delivery or transportation of packets take place, but the transport layer protocols specify how to transfer messages between hosts and are responsible for managing reliability requirement of a conversation. So the transport layer includes the TCP and the UDP that it uses when it's doing its communication, and each one of it is tied to an application. So any application that is generated from the application layer, it is either a TCP or a UDP. All right, we're going to find out what is this TCP and what is this UDP. So this is how it takes place in the OSI model. So you see in the TCP IP model, this is the network access layer where you have your LAN connection, you have your WAN connection, because it's a network access layer. And then you go to the internet layer, which is the layer 2 of the TCP IP or layer 3 of the OSI model, where you have the IP protocol. All right. Then from the IP protocol to the transport layer, where you have your TCP protocol and then your UDP. Then finally, you go to the application layer where you generate data, whether it's an FTP or you are browsing the web or you are sending email or you are doing DNS query or you are transferring files. So what then is this TCP? TCP stands for Transmission Control Protocol, and it provides reliability and flow control. Okay, it has some basic operations that number and track data segment transmitted to a specific host from a specific application. So that's just the whole essence. This guy is trying to send a message or access a particular server. And so from the point he is trying to access to the time he reaches it and back, TCP ensures that the data is safe. TCP ensures that everything done there can be acknowledged. Okay, that is what it means, right? So TCP also helps in acknowledging received data, right? It does retransmission of data as well. Another thing it does sequence data that might arrive in the wrong order. So when your data arrives, remember we said that the data will be numbered based on their sequence, the sequence numbers after they have been segmented. So they will now be sent across the network. So by the time they arrive, they are going to now begin to reassemble them. So this process of this reassembly is the sequence, is the sequencing, the arrangement of it. So TCP helps in the rearrangement of that. So sequencing data might arrive in the wrong order and TCP will arrange that. Okay. How about UDP? UDP provides the basic functions for delivering datagrams between the appropriate applications with very little overhead and data checking. That's why we say the UDP is faster than the TCP. But TCP is connection oriented while UDP is connectionless. When we say connection oriented, which means that in the case of TCP, if if uh, if this guy wants to send a message, he has to establish the connection to the destination first before the message is now transmitted over. Okay. But in the case of UDP, is connectionless oriented, which means that this guy just need to send the message here. Whether the end is established or not, it doesn't matter. The router in this particular case will decide how the remaining goes. So it's like a real life example is for TCP, for connection oriented is when you make a phone call. If I pick my phone and I dial somebody's number, the person's phone will ring. But while the phone is ringing, I cannot begin to transmit my message. I cannot begin to tell the person the message because he has not answered the call. The connection has not been established. Okay, so until the person picks and establishes the calls and say hello, then I begin to transmit my message by telling him what message I have for him or her. But when it comes to UDP, it's like sending a text message or sending an email. So if I send an email or a text message, it doesn't matter whether the person is online or not. It doesn't matter whether the person is actively there or not. The message will be delivered, but it will be delivered until the person now comes to the phone and comes and sees the message, and then he can respond. But that will not stop the message from being delivered. Okay. But in the case of connection oriented, it means that you have to establish the path before sending the message. So UDP is also known as the best effort delivery protocol because there is no acknowledgement that the data is received at the end of the destination. In the case of TCP, there is data acknowledgement. So if I'm talking with someone, I have an acknowledgement that yes, the person is listening to me and the person is understanding the point I'm trying to make. Okay, so UDP is also used for request and reply applications where the data is minimal and transmission can be done very quickly. Okay, so it is important that all the data arrives at the end and it can be processed in a proper sequence. So TCP then is used as that particular transport protocol. So for instance, the applications that you run on UDP are like phones. When you do VoIP calls, VoIP means voice over IP. It's like these desktop phones that you connect on the network and you make internet calls. All right. And so because it's UDP, it is fast. It has low overhead. It does not require acknowledgement. It does not resend loss of data. Delivers data when it arrives. Okay, so you haven't that with voice over IP. You have that with even DNS resolutions. They're all just examples of UDP. But for TCP, TCP is reliable. And then once it sends message, there is an acknowledgement. And then once data is lost, it can resend it. And then it delivers data in sequential order and rearranges them. And examples is when you're sending an email and when you are browsing the internet. Okay. Now, how does this TCP works? What are the features? TCP features include establishes a session. TCP is a connection-oriented protocol that negotiates and establish a permanent connection or a session between source and destination device prior to forwarding the traffic, like I explained earlier. So it also ensures reliable delivery. So for many reasons, it is possible for a segment to become corrupted or lost completely as it is transmitted over the network. TCP ensures that each segment that is sent by the source arrives the destination. It also provides same order delivery because network may provide multiple routes that can have different transmission rates. So data can arrive in the wrong order. So TCP helps in that. So TCP also helps to support flow control. Network hosts have limited resources like memory, processing power, and things like that. So when TCP is aware that these resources are overtaxed, it can request that the sending application reduce the rate at which the data sorry about that. So it will reduce the rate at which the data is being sent for delivery. So in the header information, what are the things that are found there? TCP, remember we said is a stateful protocol, which means that it keeps track of the state of the connection session. And it records which information it has sent and which information has been acknowledged. Okay, and in the header information, it has what we call the source port and the destination port. It also have the sequence number. It has the acknowledgement number. You see, all these details are very, very, very important because they are key to TCP, right? And then, interestingly, it also has some error checking mechanism where it talks about checksums, all right? And then you have the window size and then urgent if necessary, where you do your QoS, quality of service, and then you now put in your data. That's the header information. So let's look at each of the items in the header information. The source and destination port are actually fields that identify the application that you are using. So the destination port number is usually the application that you want to access. If you want to access a web application, for instance, you use a destination port of 80. If you want to access an FTP application, you use a destination port of 21. If you want to access whatever application, you need to know the port number that you are accessing. These are well-known ports. They are registered ports. They are well-known globally. Then the source port is dynamically created on your own system. All right. We're going to see about that. Now, sequence number is a field that is used for the reassembly purpose. Remember, we said that the transport layer will segment your data. You have maybe this size of data and you want to send on a particular channel. All right. And so what the transport layer will do is it will segment it. It will segment it, maybe segment 1, 2, 3, 4, 5. It will segment it. All right. And once it's segmented based on their sequence, so this will be sent, this will be sent, they will be sent differently. So once they arrive, there's a tendency, maybe they will arrive in this order. Maybe they will arrive in 4, 4, 5, 1, 2, 3. Maybe they will arrive in that order, you may not know. So it is the job of the TCP to now reassemble, rearrange it based on their sequence. Then the acknowledgement number is basically the field that helps to confirm that the data has been received. Data has been sent, data has been received. If data has been sent and maybe let's say 5 KB has been sent and then 4 KB received, it's not going to acknowledge it until it talks to the device and then it will resend to get the same 5 KB, right? The header length usually is the length of the header information. All right. Then the reserved is like a 6-bit field that is reserved for future use. The control bits is used that includes bits to flag which indicates the purpose and the function of the TCP segment. The control bit, yes, that's what we're saying. The window size is the 16-bit field used to indicate the number of bytes that can be accepted one at a time. Okay, that's the window size. And it will also determine the size of the segmentation that you're going to now make. There's what we call maximum segment size, and there's the minimum segment size. We're going to look at that much later. Then checksum is used for error checking. And then the urgent field indicates where the traffic is urgent. Now, there are different applications that use TCP. Amongst them are like your web application, which uses HTTP, okay? And it uses maybe port 80. Then you have FTP that uses 21. You have SMTP that uses port 25. SSH that uses port 22, and so on and so forth. So how did I know these particular ports? They are global registered well-known ports. So if you want to be good in network security, you need to know the port numbers of these applications. Because if I want to block maybe web traffic on my network, all I just need to do is block port 80. If I block port 80, then web traffic will not function. If I want to permit only SSH, all right, then I will know the port that I will now permit. So we have seen TCP. Let's look at UDP. UDP has the future data is reconstructed in the order that it is received, and any segment that are lost are not resent, and there is no session establishment, and the sending is not informed about resource availability. So that is the issue with UDP. and the header information is much smaller than that of the TCP. The header information only contains your source port, destination port, the length, the checksum, and then the data in question. Okay, then the data in question. Now, let's look at each one of them. Now, the concept of the source port, like we said, talks about the port number of the device that is generating the message. The destination port talks about the port number of the application you are trying to access. The length indicates the header field length, and the checksum is for errors. And some applications that use a UDP, we have DHCP, we have DNS, we have SNMP, TFTP, VoIP, video conferencing. All those ones, they use UDP, all right? That is the protocol that they use. So now let's look at the concept of port number, because in each of these header information, we're talking about port numbers, source and destination port numbers. So TCP and UDP transport layer use port numbers to manage multiple sessions or simultaneous conversations. Okay. So the source port number is associated with the originating application on the local host, whereas the destination port number is associated with the destination application on the remote host. So how do you now know about what they call socket? Okay, now socket is like, it's like maybe in your house you want to plug something, then you see something like this where you plug in a socket on the wall. That's what comes to our mind. But in the case of transport layer, socket is something that is very important because it relates to the ports that you are going to be communicating with. And the ports you'll be communicating with are the source and destination ports. So the combination of the source IP address and the source port number, or a combination of the destination IP address and the destination port number, is what we call a socket. So if, for instance, look at this, for instance, this is source port and this is destination port for this particular packet. So you have source port and destination port. But for you to have a socket, you must have the source port number and the source IP address. Or you must have the destination port number with the destination IP address, right? So we're going to see how we can use sockets maybe much later. But there are groups of port numbers that we need to know. We have what we call the well-known port numbers, we have the register port numbers, and then we have the private or dynamic port numbers. The well-known port numbers are port numbers that are reserved for common or popular services and applications such as web browsers, email clients, remote access, and so on and so forth. All right. They define well-known ports for common server applications, enable clients to easily identify and the associated service required. So it ranges between 0 to 1023. 0 to 1023. Those are the ports that are called well-known. They are reserved for all the major applications that we know, right? So that means there's a total of 1024 ports that are made to be known, right? Then the second one is the registered ports. These ports are assigned by the IANA to the requesting entity to use with specific processes or applications. So these processes are primarily individual applications that a user has chosen to install rather than common applications that will receive a well-known port number. So when you see banks, when you see big corporations, when you see programmers, for security reasons, they are creating applications and they are using a particular registered port. They will have to pay for that port number. Okay, so that is it. Then you have the private and dynamic port numbers. The private port numbers starts from 1024 to 49151. 49151. That is the, so you see it's a continuation. This one stops as 1023. This one continues 1024 to 49151. Then this one continues from 49152 to 65535. So the dynamic or private port numbers, usually they are the ones that your system gets dynamically or automatically. So if, like my system now, I'm browsing or I'm using certain applications, my system will generate the port numbers dynamically based on the operating system. All right, so my operating system will be the one to assign the port numbers. So let's look at some very well-known port numbers, like port 20 and 21 are reserved for FTP, File Transfer Protocol under TCP. 22 is reserved for SSH. 23 is reserved for Telnet. 25 is for SMTP. 53 is for Domain Name Service, that's DNS. 67 is for DHCP. 68 is for DHCP client. 69 is for TFTP. 80 is for HTTP. 110 is for POP3. 143 is for IMAP. 161 is for SNMP. All right. 443 is for HTTPS. These are very well-known ports. So as a security expert, you need to be conversant with these particular ports. Okay. So you see now, if you go to your system, you can now see a socket. So this is like a socket because you see the IP address and the port number, dynamic port number. So how do I get that? You just go to your Windows system and you type this command, net start. If you type it, it's going to generate all the TCP connections that you have or that you're currently having on your network, okay, or on your system. So for instance, maybe let me do that. Let me share my command prompt. Okay, so I guess my system is being shared. All right, so if I come here and I do, right, if I just put net start, see, it's going to now begin to bring out my connection. So this is a socket, an IP address with a port number. All right, so these are basically what I am doing. I'm using HTTPS, foreign address, this is it, and this is the local address, okay? This is it, and this is the port number. So here, the port number is HTTPS, all right? And that's why you see it's established. So, TCP communication process, okay? Each application process running on a server is configured to use a port number. An individual server cannot have two services assigned to the same port number within the same transport layer service. So an active server application assigned to a specific port number is considered open, which means that the transport layer accepts and processes segments addressed to that particular port. Any incoming client request addressed to the correct socket is accepted, and then the data is passed to the server application. And that's what we're saying. I have client 1 here and I have client 2 here. And the server is talking to both of them, right? And it's talking to both of them on different protocols. Like client 1 is talking to it on HTTP, which is port 80. For client 2, the server is talking to it on port 25, which is email. What does it mean? That this server is multitasking. Is multitasking. So I can have a server that carries multiple services. All right? That is just what it means. So how is this connection established? There's what we call the three-way handshake. All right? You're going to see about it very soon. So we're saying step 1 is to initiate the initiating client requests a client to server communication session with the server. That is this guy. Is the guy that sends the first initiation. Then step 2, the server acknowledges the client to server communication session and requests a client to server communication session. So this guy now accepts it, which is the server. Then step 3, the initiating client acknowledges the server to client communication sessions. And then that is it. So the three-way handshake is complete. Once it is complete, then transmission of data begins. All right? Transmission of data begins. Now, if you want to terminate that particular session, the client will now send the FIN message to the server. And then step 2, the server will send an acknowledgement receipt to the FIN that was sent, right? To say I've received the acknowledgement. So you send the ACK, which is the acknowledgement. It will also send a FIN to the client to terminate the server to client session. All right. So it's okay, you have terminated from your end. I'm also terminating from my end. After which the client will now respond with his own acknowledgement. So that is what happens. So the function of the three-way handshake is that it establishes the destination device is present on the network. It verifies that the destination device has an active service and is accepting requests on the destination port number that the initiating client holds to use. It also informs the destination device that the source client intends to establish a communication session on that port number. So after the communication is completed, the sessions are closed. The connection is terminated. The connection and the session mechanisms enable TCP reliability function. So that is the function of the three-way handshake. But there are certain flags. Remember, in the header information, there is a column where it talks about the control bits. And in that control bit, there are certain information that is being put in there to explain what happens or maybe flag certain situations. If what is inside there is URG, which means urgent pointer field is significant. If what is there is ACK, which is acknowledgement. PSH is push function. RST is reset the connection when an error or timeout occurs. SYN is synchronized sequence numbers used in connection establishment. And then FIN, no more data from sender and used in session termination. Reliability and flow control. So TCP can also help maintain the flow control of packets so that devices do not become overloaded. Very, very, very important. So that they don't become overloaded. There may be times when TCP segments do not arrive at their destination or arrive out of order. So you could see this is the data here. And this data is segmented into 6 in this case. So by the time they are sent, you see that they arrive 1, 2, 6, 5, 4, and 3. All right. So they are not going to arrive, they will arrive out of order. So reliability feature under TCP will now rearrange to make sure you have 1, 2, 3. Hello, can we? All right. Thank you. So 1, 2, 3, 4, 5, 6. So it's going to now rearrange them just to ensure that everything is fine in that area. So no matter how well designed the network is, data loss occasionally happens. So TCP provides a method of managing this segment loss. Among these is a mechanism to retransmit segments for unacknowledged data. So if this guy is sending the data to system B, you see it has sent segment 1, 2, and then 3 and 4 got lost on the way. And then it sends the rest. By the time the system is trying to rearrange and it noticed that there are 2 segments, 3 and 4, that were not sent, okay, because there was an error, it will now have to request for the resend of that. Okay, it will send acknowledgement for all the others, but since the other 3 and 4 did not get acknowledgement, then it will resend it so that you can get the acknowledgement. So that is how it, it works. Now, flow control and window size are also very, very important. The TCP provides flow control mechanisms, and the whole essence is to ensure that from source to destination, there is no problem. Flow control is the amount of data that the destination can receive and process reliably, okay, so that you don't overload it. That's where you have what we call the maximum segment size, right? So the flow control helps to maintain the reliability of the TCP transmission by adjusting the rates of data flow between the source and the destination. So what it happens is that they will have to do some negotiation between the source and the destination using the medium that is there to say, okay, how much can you chew? How much can you take? All right. And this happens during the three-way handshake process. So, for instance, this guy will send a window of maybe 10,000, then it will now be received and then broken down. Say, what I can take is this size, this size, this size, and this size. So if it is the window size of 10,000, fine. Then it can be sending the message in that. If it is less than that, fine. It will now make the agreement. Okay. So the maximum segment size is the maximum amount of data that the destination device can actually receive. And a common maximum segment size on most devices is 1460 or 1460 bytes, especially in IP version 4. So when you're using Cisco devices or most other vendors, that is what you see. In some cases, you'll see they will put 1500. 1500 is not the maximum segment size, the maximum transmission unit. All right. So the maximum segment size minuses about 40 bytes that is meant for the header itself. All right. So everything is like 1500 as the maximum segment size. All right. So finally, we go to UDP communication. UDP does not establish connection. UDP provides low overhead data transport because it has a small datagram header and no network management of traffic. Okay, UDP does not track sequence numbers the way TCP does. UDP has no way to reorder the datagrams into their transmission order. UDP simply reassembles the data in the order that it was received and forwarded to the application. So UDP-based server applications are well known for their registered port numbers. All right, UDP receives a datagram destined for one of the three ports. It forwards the application to the appropriate application based on its port number. That's how it works. So how does the client do its processes? Because we have client one here, you have client two. What happens is that the UDP client process dynamically selects a port number from the range of port numbers that uses this as the source port. So which means this guy will dynamically get a number from the operating system. All right. And you see that it will get the number, maybe a source number or a destination number. All right. And then it will now be using it to talk to the application. Now, in this case, you see that the radio server is using a port number of 1812. 1812. So if this server wants to talk to this PC, it will use a source number of 1812 and then the destination number of the you see here is 51152. This 51152 is a number that was generated automatically by the operating system. Okay, so if I am going to use 5 browsers, or even if it's one browser and then 5 tabs, then it's going to generate for me 5 different dynamic port numbers as a host, as my laptop. Okay, but the server only produces one, which is a fixed port number. All right, so this is all that we have for today's class, TCP process, transmission control process protocol. And in summary, what we have agreed is that it is the layer 4 process of the OSI model, 4 layer of the OSI model, or the layer 3 layer of the TCP/IP protocol suite. 2, we said that the PDU is known as segment in this particular layer. And it's known as segment because it picks the data and then segments it based on the size of the channel at which it's going to convey. We also said that it has header information, and the header is based on the protocol, which are the two major protocols of the TCP. The two major protocols are the TCP and the UDP. All right. These are the two major protocols of the transport layer, TCP and UDP. All right. We said TCP is connection oriented. TCP helps to give acknowledgement. TCP verifies your transmission. TCP is connection oriented and things like that. UDP is connectionless oriented. UDP is does not use best effort like TCP and so on and so forth. So we looked at the differences between TCP and UDP. We also looked at the concept of the port numbers, where we agreed that we have different port numbers which are used in the communication process. There are well-known port numbers where applications that are well known to us use, like web, HTTP for web, for DNS, for DHCP, for FTP, and for all the other applications. All right, they have their well-known ports. We also have registered ports, and we said those registered ports are provided by IANA, which means that for you to use those ports, you have to go and pay for it. Okay. Then we have also the dynamic ports or the private ports where the system generates dynamically. Okay. We also talked about the window size and the three-way handshake, where we talked about the maximum segment size and maximum transmission unit. We also talked about the process that the system goes when it's trying to form the three-way handshake. So, in summary, that is what we have covered for today. So I'm going to give the forum for question. So while the question is going on, I'm going to enable our attendance. So I have a hand here, Dr. Gift Adene. Please, you can ask your question, and then the attendance will come up immediately. You can ask your question, please. Dr. Gift, are you there? That's Adenaya. Okay. Dr. Osho Steven, can you ask your question?
Good evening, sir.
Good evening.
Good evening, sir.
Good evening.
Okay. Uh, I want I want to know more about this private port, because we have assigned ports and well-known ports. So this private port, when do we need to use it? Is it that, well, if I want to connect, for example, I want to connect my system to a printer. That's I want to communicate with a printer, all internally connected device. That's when I use these private ports.
Okay. This is a very good question. Let me use this as illustration. This is a PC, and this PC wants to talk to this server. This particular server functions at port 80 because it is a web server. Now, for this PC to talk to this particular server and this server to respond back to this PC, there must be a port number. Both of them need to have a port number. This same PC is trying to carry out another activity, FTP, that runs on port 21. For this PC at the same time to talk to this guy and this guy to respond back, both of them need port number. This PC can have multiple services it's trying to access. So what are we talking about here? If this is port 80, how do we know it's port 80? Because the person that built this server or this application used port 80 as a well-registered port. The person that built this server or this application used port 21 as a well-registered port. But your own PC has an operating system. And the operating system that you have, whether Linux, Windows, or whatever it is, Android or Apple, whatever application operating systems you have, is configured to have dynamic or private port numbers. This is a range of port numbers that are there on your system. What do? Anytime your PC wants to access maybe this server, your operating system will just look for a port number at random and assign. Let's say maybe it gives you 3121. So it gives this PC a port number at random so that there will be communication between these two. So this server will now know, okay, I am communicating with 3121. The moment this is going on, the same operating system is giving the same PC another dynamic number, maybe 5271. I'm just picking the numbers randomly. The same is giving this so that this guy can be able to do here. So one PC may have multiple port numbers. And the port numbers are generated dynamically. So you call them private or dynamic port numbers. Okay? So I don't know whether that
Okay.
answers your
No,
question.
no. Yes, you make one statement just now. You say private or dynamic number. So my own question on that, I want the different. I want the difference between private and assign port number.
Okay. Let me go back to the slide so that you will.
Because assuming that, okay, let me put it the other way around again. Assuming that I'm not connecting to any remote host, will my system still make use of port number?
No. The port number is just for you to communicate. That's all.
With remote or with a remote system, that remote
Yes.
host.
Yes.
So if I'm connecting within connected device,
Eh,
I don't need I don't need no port number.
if you're connecting within connected device, I don't understand.
For instance, now I want to
As in
connect to a printer.
a local
That I
network.
want to send a communication
You're
to a
connected to a
printer.
printer.
Then I need
What
any port
what
number
what it,
for
what it
the
does the
operator
print?
to communicate with the printer, for
Okay.
example.
All right. Maybe let me put it this way to you so that you will understand. Um, have you tried browsing before?
Yes,
Good. When you are browsing, what do you think you are doing? You are accessing a service. Is that not so? That
yes.
kind of service you are accessing is called a web service.
Okay.
Now, that web service that you are accessing, the person that built that server gave it a port number 80 because you are using web. For instance, now, let me see if I have any service on my C. Okay. No, I don't have. Okay, I wanted to show
Hello,
you there's a,
hello, sir.
yes.
Can I be of help?
Okay, please go ahead.
Please, I think you should make clarifications to us that the port we are talking about, they are not port like USB port or network switch port.
Oh,
They are application ports.
now I get the confusion.
Yes, sir.
I get,
That
thank
could,
you very, very much.
they are service ports. Yes.
They are not physical
Application
ports.
service port. Yes, yes.
They are not physical ports on your system. They are just numbers. They are service ports. They are not physical ports. So if you are connecting your printer, you are using USB. The USB port that you are talking about is not the port numbers we are talking about. I don't know whether you get what I'm
No,
saying.
I understand. I'm getting you.
It's not that. So the service port that we are talking about is basically to help aid communication between remote devices,
They are virtual ports.
not between hardware devices.
Can we say they are virtual ports?
Yes. Okay, for instance, IP address.
They are virtual.
IP address, when you're using IP address are virtual addressing on your system. Is that not so? They're just
Yes.
numbers that helps identify your system. They're just numbers. IP address are numbers that helps identify your system so that your system can talk to other systems. It is the same
They are
thing.
logical.
These port
Logical
numbers are
IP.
just numbers that help you
Virtual.
identify.
Logical.
Hello?
I'm getting you. I'm getting you.
All right. So I don't know whether that is clear or I should still give some other explanation.
No, I will still do, it's okay. I will still do my own research.
Hello, sir. Hello,
Okay.
sir.
Yes.
Okay. Initially, it was asking about the private and the dynamic.
Mm.
I guess maybe wanted to know what if you are within a local area network and you are not connected to the internet? You're not routing
Exactly.
outside. And probably a PC want to communicate with a printer. What kind of port will it use
Will
to
you use?
handle the printing
Exactly.
services?
That is it.
Okay. Now, let me ask you, are you aware that we have different types of printer? We have network printer, we have a local printer. Are you aware of that?
Yes, we know that. I
Very,
know that.
very good. And are you
Yes, sir.
aware that the communication process between a network printer and a local printer is different?
Yes. If you connect that printer as a network printer, because I can decide to also connect that printer as a local printer if I connect it direct to the system. But if it's connected to a switch or to a hub, because through maybe any of the connecting ports using RJ4500, it become a network printer.
Okay. Okay. Let me put it this way again. If I carry a network printer, that network printer is not directly connected to my PC. Is that correct?
Yes,
That
yes,
network printer is connected to my network. That's why it's
yes,
called network printer. Any device
Yes,
also connected to that network will access the printer.
Printer, very well.
Then also, do you understand that
yes,
concept?
yes,
Very good. If you understand that concept,
sir.
that printer is a print server. And for my PC to be able to talk to that particular printer, it requires certain process, communication process that we're talking about. All right? It requires communication process. If I carry a local printer and I connect a USB cable from my PC to the printer, it is a direct connection from my PC to a printer. It has nothing to do with my network interface card. It has nothing to do with the transport layer because it's a USB cable that I'm connecting directly to my printer. So if that is the question you are asking, the USB cable has nothing to do with the transport layer that we're talking about. But if the printer you are talking about is the network printer, then it has something to do with the transport layer that we're talking about because there's going to be a communication process on the network interface card. The network printer has a network card. The laptop has a network card. So the network is going to see the printer as an end device. Your laptop is an end device. The printer is an end device. So they are going to have a communication. And in some cases, there's even a switch in between them. So there must be a communication process and it requires this process. So the application that the printer is require that port number. But if you are using a printer directly, USB cable, or you are using there's this parallel port cable of olden days that they are using, then it has nothing to do with the TCP/IP, the transport layer. Is that clear enough?
Okay, yes, I think it's a bit clear now. It's a bit clear.
All
It's
right.
clear. It's okay. So,
Oh,
but the second question is that about window size.
yes.
Assuming that my system, I'm communicating. That is, two systems are communicating. Which of the system determine the window size? Is it the destination host or the source host that determine the window size? Assuming that two of them are using the different IP. Assuming that one is using 4, one is using 6. Which of the system that determine the window size?
Okay. Now, it is like me, or maybe you have a child and you want to spoon feed your child. Okay? You have food you want to be feeding your child. If you fool the spoon and you want to put in the mouth of the small baby, do you think it will enter the mouth of the small baby?
No.
No. So who then determines the size, the window size?
The receiver.
Correct.
Well, okay.
Correct. So the person that is sending is the one that will send the request. You understand? And then the receiver will say, oh, this is the maximum I can take. Are we together?
Okay.
So that is what happens there.
Okay.
Is that clear enough?
That is clear. That is clear. That is clear.
Good.
Thank you.
You're welcome. All right. So I see next one, Ojo Olufemi and Arinyo. You can ask your question.
Okay.
This is
Yes, sir.
George.
Yes, sir. I'm okay, sir, except for the question that I asked yesterday.
What is the question?
Okay, can I reiterate the question?
Is it the question about the router, how to add interface?
Yes. Add interface, extra interface. Yes.
We have answered that question.
Okay, Ali. Oh, okay.
Yes.
Okay. All right, I will watch the video. No problem. Thank you very much.
You're welcome.
Hello, sir. This is Israel, sir.
All right. So go ahead, Israel.
Okay, sir. Please, sir. The questions and answers, because I discovered that you will stop the recording. The main class is a separate class. So are you sending all the separate recordings for the question and answer to the WhatsApp so that we'll be sure?
Yes, I will
Okay.
do that.
Okay, sir. Okay, that's for that. Also, sir, please, I'm trying to solicit for something so that it will help us. I mean, maybe some people too will be happy with this. Please, sir, the ITN practice exam and the ITN final exam, they are two different things. What I'm trying to solicit for is that, please, sir, for me, because the question on ITN practice PT exams is just helping us to buttress more on everything you are saying. If we can have that unlimited, because it's having just two trials. If you can remove the trials for the practice exam, that is the ITM practice exam, then the final exam can still remain the way it is for the practice, so that we can keep, when we make mistake, the thing fails us, we come back again. We make mistake till the program is over. Please, sir, that's what I'm soliciting for.
All right. So I'll look into that.
Yes, sir. Thank you, sir.
And then finally, Adebowa.
Adebowale.
Adebowale.
Right, good evening. We were told that IP does not check error, and the error is being taken care by UDP, by the layer 4 protocols. But you said UDP is a connectionless protocol. In other words, doesn't check the error. Am I correct?
No, it checks errors. If you check the header that we showed, you check the headers, there is error checking. Where is it? Both of them have errors. Okay. Right. You see where it says checksum? And you see checksum on UDP header. So it is used for what? Checking errors. So it checks errors.
Okay, thank you, sir.
You're welcome. All right, so ladies and gentlemen, thank you. It's been a wonderful session with you guys. Very engaging, and I like the way you ask your questions. I tell you, the best way to learn is to ask questions. The best way also to get out of whatever the instructor is teaching is also to ask questions. So I may just teach, but if you ask questions, then we have opportunity to go a little deeper. So thank you so much for your participation. It's been lovely. Thank you for your attendance. Today is Sunday, so we see on Thursday. So have a very good night.
Oh, thank you.
Thank you,
Tomorrow.
sir. Thank you.
Good
Bye.
night.
Good night.
Bye
Thank you,
bye.
sir.
Wonderful
Bye.
session with you, sir. Thank you so much.
Bye.
Nice